This video is an introduction to how to draw use case diagrams. Use case diagrams are part of the Universal Markup Language UML2 specification. Use case diagrams give an overview of how a system is to be used. Use case diagrams are used typically to communicate with non-technical people. They don't give a lot of knowledge to technical people, but are a great way to start to gain an understanding of the system and to communicate a system, its boundaries, and its various working parts. One other thing about a use case diagram, completeness is not as important as the communication of the entire system is. Use case diagrams are made up of three basic shapes: use cases, actors, and relationships, also called associations between the actors and the use cases. There is an optional shape known as the system's boundary, which is basically a rectangle around parts of the use cases of a system, but we're going to not discuss those in this introduction, but you will see them in the materials online. The first shape that we're going to discuss is the use case, or the oval with a use case description inside the oval. According to the specification and one of the authors of the material that I'm using, it says a use case describes a sequence of actions that provides a measurable value to an actor. So think about any process in the system that either takes data from the user or delivers data back to the user or delivers something back to the user, and it's drawn with an oval with a description inside. The use case diagrams, the use case symbol's name should begin with an action verb. Always begin the use case with an action verb. In that use case symbol, you're more than happy, or it's perfectly more than all right to use domain-specific jargon or terms in the use of your use case names, because this diagram is used to communicate, usually with stakeholders. They understand the terminology you're going to be using. And then when you're arranging use cases on a page, it's usually best to arrange them in a chronological or systems order from the top to the bottom and the left to the right, just the way we normally read in Western societies. So be sure they begin with a verb, an action verb. You can use jargon and abbreviations in them, that's okay, and kind of arrange them in an order that makes sense. The second shape is the actor, and we draw the actor with a stick figure with the name of the actor underneath the stick figure. According to the author of, again, my reference material, an actor is a person, organization, or even external system that plays a role in one or more interactions with your system. So be sure that only actors that play a role in your system are included in your model. A couple of notes about actors. Actors should be given a singular noun name, customer, billing system, or others. Include the less than, system greater than. Include the word system for other systems that are actors, because actors don't necessarily always have to be people. They could be other systems that your system is feeding data to or getting data from. And then create an actor called time for any of those kind of temporal use cases. For instance, a use case that happens on a periodic basis, once a week, once a month, once a day, those kinds of things. You can create an actor called time to show that it's triggered by something else. Remember that roles are not people or positions. It is specific actor. I want the actors to be thought of as to their function, not their people or their position. So don't make Bob an actor or the vice president an actor. Let's put the roles of the people, let's put the roles of the actors instead of those kinds of names. And the other thing is, actors don't interact directly with other actors. Actors direct only with use cases, and use cases will interact back with actors. Relationships in use cases are lines that connect actors and use cases and can connect use cases to use cases in special instances. We're going to talk about the association between an actor and a use case. We're going to talk about the associations, a couple of different types of associations between two use cases. There are also relationships in the standards that go into generalizations between two actors and between two use cases, but that's again beyond the scope of this introduction. Relationships. The relationship between an actor and a use case is usually done with a solid straight line. This means that the actor is giving the use case something or taking something away from the use case, or in many cases both. So when an actor gives the system the information to do something or to do something else, you can also see that in this example, one use case is fed by multiple actors, and one actor feeds multiple use cases, which is often the situation in business. The next type of relationship that I want to talk about is a relationship called the extend. An extend is when we create a more complex use case that takes the previous use case and builds upon it. Makes sense, that's why we call it the extend. You can see here in our example, to order dinner and dessert would extend upon the use case to just order dinner. The arrow is dashed and points from the base case to the more complex case to extend it, the extend. The last relationship I would like to talk about is the include relationship. The include relationship is how we can take a small use case or a little piece of a use case and then include it into a bigger use case. The extends relationship allows for an optional path or a more complex path or more complex use of the system, where the include allows us to split a little piece out and move it off into a smaller use case to simplify the big use case by including little bits, and also to be able to reuse the little bits in other use cases. Now that we know all of the shapes, the use case, the actor, the association between an actor and a use case, and the two associations between use cases that we've covered, the extends and includes, we can now draw a simple use case diagram. For instance, take a look at this one. This is a doctor's office or a hospital situation where a doctor performs a medical service with a patient. After the doctor performs the medical service with the patient is sent a bill. The process of sending a bill doesn't include the doctor anymore, it includes the billing clerk, the entity. The billing clerk sends the bill, and also notice that the bill could be sent to the patient or to an insurance company, or both. Once the patient or the insurance company makes a payment, the billing clerk is also involved in the making the payment process or receiving the payment process. It could have been called that in this case. And then lastly, the billing clerk may adjust, write off, or do something else to the bill. So this covers the whole process of the doctor creating the bill, the bill being sent out to the patient or the insurance company or both, the patient or the insurance company or both sending in a payment, and the billing clerk writing off the balance or adjusting the invoice, adjusting the bill to make sure it shows as paid. Our next example is for my friend Bubba and his computer repair business. What we're creating is an RO or a repair order system for Bubba. So a customer can start a repair order, and the customer could start an on-site repair order. See, Bubba's business works two ways. You can either bring a computer in to his shop and he'll fix it there, which is a standard repair order, or you can call him and he'll schedule a tech to come see you. The Starting an on-site repair order, or where the tech comes to see you, is a little bit more complex than just somebody dropping a computer off. So we see how that would extend the basic normal repair order to have an on-site repair order. Let's look at the next little bit. The tech would then be assigned a repair order, and I probably could have put a time entity to say that at some time during the day techs are assigned repair orders, or maybe not. A tech could then add a part to a repair order. Notice that there's an add special order part. For instance, if the tech needed to apply a special order part to the repair order, you can see that there's also a connection to a supplier. And it extends a part, a regular part, because if it's an inventory part, that'd be the simple one. A special order part would be applied to the repair order the same way as a regular part, except it also needs to be ordered. You can see how that extension and the supplier entity or the supplier actor comes in. And then last, the tech can send a complete repair order to billing. So once the repair order is done, once the computer's done, the tech sends it to billing, and it goes out to the billing system. There's a whole other system that handles billing, accounts payable, accounts receivables, and all of those things. This is just the repair order system, and you can see how we connect from one system to another through a system actor. Our third use case example brings it all together. Imagine you're walking into, or you need to write a system for a small bank to handle loans. They have student loans and personal loans and car loans. Let's think about a personal loan and a student loan, because they're neither secured loans like a car loan. So a car loan or an automobile loan would be a different kind of loan. A borrower talks to the personal loan. Let's look at the one in the middle first. A borrower connects to the personal loan. The loan officer connects to the personal loan. The personal loan and the automobile loan both include the credit check, because that goes out to a credit bureau, an outside service, an outside actor to decide. And also then notice that a student loan, which connects also to the borrower and loan officer actors, extends a personal loan because it also includes contacting the university to see if they're actually enrolled. So you can see how the student loan is just like a personal loan and extends the personal loan. And because of the extension of the personal loan takes care of the credit check, because the credit check is included in the personal loan and the personal loan is extended into the student loan. So that's why there isn't also an arrow from the student loan back to the credit check, because of the extension as well as the include. So this is a full-blown example of use case modeling. So at this point, you've seen a simple introduction to use case diagramming, and you should be able to do use case diagramming. On the next slide, you will see several works cited that were used in the preparation of this slideshow, in the preparation of this video. Please use those and go out and do some additional research in use case modeling if in fact you